All right, so in this chapter, we want to look at some quantitative calculations for chemicals. We want to know how we can measure the amount of chemicals that we're going to need for any chemical reaction. When we do chemical reactions or when you plan a synthesis, keep in mind that nothing is random. We don't choose our material randomly, and we also don't choose a random quantity of each reactant. So in order to do any chemical reactions, we need to know exactly how much of each material we're going to need. So we're going to learn how to do that. And also, if we're aiming for a specific amount of product, we're going to learn how we can choose the amount of reactants. So in order to be able to answer these questions, we're going to introduce to you a new term, which is the mole. Mole is going to be the unit that we use in order to count any sort of chemicals. And once we understand what mole represent, then we're going to show you how you can actually calculate the number of moles, the mass of each chemical or material needed during a chemical reaction. And then we show you some applications of the concept of mole and how it's used in order to identify or come up with a formula of unknown material in a synthesis of compound. So let's start with mole. So everything around us in our daily life has a unit. So when you count anything or when you measure any quantity, it has a unit. So the unit that we use in order to measure the amount of material is called the mole. So mole is defined as anything that contains 6.022 times 10 to the 23 objects. So 1 mole of anything contains 6.022 times 10 to the 23 of that object. Now, so what this means is that if I say 1 mole pen, 1 mole of pen contains 6.022 times 10 to the 23 pens. If I say 1 mole, let's say chairs, that's 6.022 times 10 to the 23 chairs. Now, this 6.022 times 10 to the 23 is called Avogadro's number. Avogadro was the scientist who was able to actually measure this number for a mole. He didn't get credit for it while he was alive, but it was named after him when scientists were able to actually confirm that each mole is 6.022 times 10 to the 23. So Avogadro did an experiment, and with the experiment he came up with this number. So 6.022 times 10 to the 23, memorize this, please. This is Avogadro's number, and keep in mind that Avogadro's number gives you the ability to convert in between number of moles and number of units. So if I say 1 mole sodium atom, that's 6.022 times 10 to the 23 sodium atoms. Now, what might have caught your attention is this number, 6.022 times 10 to the 23, which is a very, very big number. But also keep in mind that atoms are extremely small. So this number should make sense. But that is right, this number is a huge number, but also keep in mind that atoms, molecules are extremely small. So again, just to show you that the mole, we're going to use it to show atoms, molecules, electrons, ions, and regardless of the unit that you're looking at, 1 mole of any unit contains 6.022 times 10 to the 23 of that unit. Now, if we're looking at 1 mole of atoms, that's 6.022 times 10 to the 23 atoms. Now, 6.022 times 10 to the 23, that's the number of atoms that exist in 1 mole of, for example, atoms. Now, this equality between mole and Avogadro's number, we can use this as a conversion factor in order to convert in between the number of moles and number of units. So we can write this as a conversion factor. So each mole is 6.022 times 10 to the 23 unit object count, whatever you call it, or you can tell each 6.022 times 10 to the 23 is 1 mole of the object. So these two are going to be the conversion factors that are going to be used. So conversion factors for converting in between number of moles and number of units. So whenever you hear number of something, number of atoms, number of molecules, number of ions, that means Avogadro's number. So these two conversion factors are the two conversion factors that we will be using in order to convert in between number of moles and number of units. So I just told you that mole is Alright, so we just mentioned that number of moles is the unit that we use in order to count any quantity. Now, the fact is that when you go to a chemistry lab, and you've been to a lab by now, have you ever seen an instrument that measures the number of moles for quantity? Yes, we don't have anything in the lab, in the laboratory, that measures the number of moles. No such a thing that we can go and measure, I don't know, 4.5 moles of sodium atoms. What we have, though, in a lab is balances. So balances read in grams. They read the mass of any material or any compound that we have. So we should be able to convert in between the number of moles and mass of different materials, different chemicals. So what allows us the ability to convert in between moles and mass is going to be the molar mass of any compounds. So if you look at your periodic tables, for each of the elements, we have already defined two numbers. The number that's on the top, which represents the atomic number, and atomic number was the number of protons. However, the number that comes on the bottom is the atomic mass. Now, atomic mass for each element represents the mass of 1 mole of that element. For example, if you look at the periodic table, so the mass of one individual hydrogen atom is 1.008 AMU. So the mass of one hydrogen atom, one individual hydrogen atom, is 1.008 AMU. Now, if I look at the mass of 1 mole hydrogen atoms, it is 1.008 grams. All right, so all these atomic masses in the periodic table, if you look at the mass of 1 mole of that element, the unit is going to be in grams. So that, since you're looking at a mass of 1 mole of that element, the unit becomes grams per mole. For example, if you look at, let's say, nitrogen, the mass of one individual nitrogen atom is 14.01 AMU. But we don't use AMU in the metric system or in the SI. AMU is not SI unit. However, you can look at it this way. The mass of 1 mole nitrogen atoms is 14.01 grams. Now, if you're looking at a mass of 1 mole of any element compound, that becomes the molar mass. So molar mass is basically the mass of 1 mole of atoms, elements, compounds, any material. Now, the unit for molar mass is grams per mole. Now, the mass of individual elements, their atomic masses, I say atomic mass because they're individual atoms, elements, are already given in the periodic table. Now, the question is that if we have a compound, remember, are those materials that are composed of 2 or more elements. So if we have compounds, how do we find the molar mass of a compound? And this is important because let's say I go to the lab and I want to measure out 2 moles of water. So water is composed of hydrogen and oxygen. Now, how would I know what the molar mass of water is? So in order to find the molar mass of any particular compound or molecule, you look at the formula of that compound. For example, here we want to find the molar mass of calcium fluoride. Calcium fluoride is composed of 1 calcium and 2 fluorine. Now, to find the molar mass of calcium fluoride, you're going to add up the atomic mass of 1 calcium, and we read that from the periodic table, which is 40.08 grams, plus 2 fluorines, and that gives you 78.08 gram per mole. Remember that the molar mass, the unit for molar mass, is grams per mole. So to find the molar mass of just elements, you look at the periodic table for individual atoms or just elements. Now, if you're looking at a molecule, you look at the chemical formula of that compound. So you take into account the type of element that compound is composed of and also the number of elements. And you just add them up together to find the molar mass. Now, why is this important? Because we want to show you in the next couple of slides how to convert in between mole and mass. And it is important because in the lab, technically, we can just measure a mass of any compound. We can't measure moles directly. So we're learning what a molar mass is so we can convert in between moles and mass. So let's look at an example and see how we can use molar mass as a conversion factor to convert in between moles and mass. So here is the question. How many moles of lead does 15.0 grams of lead represent? So how many moles of lead does 15.0 grams of lead represent? So let's first of all identify what's given to us and what we're solving for. So the mass of lead is given to us, and we're trying to find moles of lead. So whenever you're doing conversion, so for any conversions, between mass and mole, so mole to mass or mass to mole, you use molar masses. So keep that in mind, that whenever you're doing any conversion in between moles and mass, now you could be going from mass to moles or moles to mass, you'll use the molar mass. So in these questions, we're going from mass of lead to moles of lead. So the only thing that I know that gives me the ability to convert in between moles and mass is the molar mass of lead. So if you look at the periodic table, the molar mass of lead is, yes, it's 207.19. So looking at the periodic table, I know that 1 mole lead is 207.19 grams of lead. So I'm going to write my conversion factors based on this equality. So I could say either 1 mole lead is 207.19 grams of lead, or each 207.19 grams of lead is 1 mole of lead. So these are the two possible conversion factors. Now let's start with what's given to us. What's given to us is 15 grams of lead. Now in between these two conversion factors, you want to choose the one in which grams of lead cancel out, and you want to end up with only moles of lead. So I'm going to choose the first one. So 1 mole lead is 207.18 grams of lead. Now mass of lead and mass of lead cancel out. That gives you the number of moles of lead. So let's all do it with the calculator and make sure that we all get the same answer. So the answer is 7.24 times 10 to the negative 3 moles of lead. So here I made a little mistake here. I used 19 here, but then, so let's fix this. This is supposed to be, yeah, it should be the same. I just made a mistake here, so 19. But let's see if that affects the final answer. Yeah, the final answer is still the same. So let's look at another example. You want to know the number of moles of mercury in 23.0 grams of mercury. So how many moles of mercury does 23.0 grams of mercury represent? So for this question, again, the mass of mercury is given, and you're trying to find moles of mercury. So since we're converting in between mass and mole, that tells me I gotta use the molar mass of mercury. So looking at the periodic table, I know that each mole mercury is 200.59 grams of mercury. Now, based on this equality, we can write conversion factors, two possible ones. So 1 mole mercury is 200.59 grams of mercury, or we can tell each 200.59 grams of mercury is in 1 mole of mercury. So now let's start with what's given to us. What's given to us is the mass of mercury, which is 23.0 grams of mercury. Now, in between the conversion factors, you want to choose the one in which grams of mercury cancel out, and you want to end up with only moles of mercury. So I'm going to choose the first one. So 1 mole mercury is 200.59 grams of mercury. So grams of mercury cancel out. And you want your answer in 3 significant figures. So this is 1.15 times 10 to the negative 1 moles of mercury, which is B. Now, a couple of things that I want to bring your attention to here. First of all, when you look at significant figures, remember that conversion factors don't count for significant figures. So what you're going to be looking at is the unit or the quantity that's given to you. For example, here, 23.0, that has 3 significant figures. You want your answer to also have 3 significant figures. Now, the other thing that I want to bring your attention to is the way I'm writing this. Please note that next to each quantity, there is a unit, and then a chemical formula for what it represents. All of this has to be in here. These type of calculations are going to get more complicated, so we want to get used to the habit of writing everything now, because later on it's going to be hard. Now, this is the only correct format for writing this. I have 23 grams of mercury, so I gotta show that it's 23.0 grams of mercury. So next to each quantity number, there has to be a unit, and there has to be a chemical formula that represents that quantity. So let's look at another example. Oh, we just did this, right? We just did this. Let's move on to another one. How many titanium atoms are contained in 7.80 grams of titanium? How many titanium atoms are contained in 7.80 grams of titanium? Now again, before you do anything, before you try to solve a problem, first you want to come up with a solution map. Have a plan of how you're going to solve the problem before starting to actually write. So a good point of start is, first of all, writing what's given to you and what you're solving for. So what's given to me is the mass of titanium. What I'm solving for is the number of titanium atoms. So from mass of titanium, you're trying to find number of titanium atoms. Remember, whenever it's about number of atoms, ions, molecule, compounds, that represents Avogadro's number. But also remember that Avogadro's number only gives you the relationship in between moles and number of atoms. But we don't have the number of moles of titanium here. So this is how I'm approaching this. In order to find the number of titanium atoms, I need to know how many moles of titanium. But I don't have the moles of titanium. So my plan should be from mass of titanium. You should figure out first moles of titanium. And once you have moles of titanium, then you can find number of titanium atoms. So 2 steps. So let's start. Mass of titanium is given to you, which is 7.80 grams of titanium. Now, in order to convert to moles of titanium, I need the molar mass of titanium. So you're going to look at the periodic table to find the molar mass of titanium. So each mole titanium is 47.90 grams of titanium. Now, grams of titanium cancel out. I end up with the moles. That's step 1. Now, from moles of titanium, I want to go to the number of titanium atoms. For that, I'll need to use Avogadro's number. So each mole titanium contains 6.022 times 10 to the 23 titanium atoms. Now, moles of titanium cancel out. Look at our unit. We end up with the number of titanium atoms. Now, let's solve this. Use your calculators to solve this. So the answer should be 9.81. So 9.81 times 10 to the 22, and the units is titanium atoms. So let's do more practice problems. What is the mass of 2.13 times 10 to the 18 atoms of lithium? All right, so let's see what's given to us and what we're solving for. So the number of lithium atoms are given to us. So number of lithium atoms is given to us, and we're trying to find the mass of lithium. So remember that the only way we can find the mass is by having the number of moles. That's the only way we can find mass, because we can use molar mass to find the mass. But we don't have moles. So our first step should be converting from number of lithium atoms So from number of lithium atoms, we want to convert to moles of lithium, and then from moles of lithium to mass of lithium. So starting with 2.13 times 10 to the 18 lithium atoms. To convert in between the number of atoms and number of moles, we use Avogadro's number. Each mole lithium contains Avogadro's number of lithium atoms. So they cancel out. Now to convert in between moles and mass, we're gonna have to use the molar mass of lithium. So 1 mole lithium is 6.939 grams of lithium. So let's put this in the calculator and see what the answer is. So the answer is 2.939 0.46 times 10 to the negative 5 grams of lithium. So to go from moles to mass, so moles of silver is given to us. And you're trying to find the mass of silver. So going from moles to mass or mass to moles, we use molar mass. So 1.05 moles of silver. And we know that each mole silver is 107.87 grams of silver. So moles and moles cancel out, and you end up with the mass of silver, which is 113 grams of silver. All right, let's look at another example. What's the mass of 8.21 moles of potassium? So moles of potassium is given to us, and from moles of potassium, we want to find the mass of potassium. So moles of potassium is given, we're trying to find mass of potassium. So 8.21 moles of potassium, and in order to go from moles to mass, we're gonna have to use the molar mass of potassium. So each mole potassium is 39.10 grams of potassium. Now moles of potassium cancel out. And the answer should be 321 grams of potassium. How many sulfur atoms are in 2.27 moles of S8 molecule? So moles of S8 molecule is given to you, and you want to find the number of sulfur atoms, individual sulfur atoms. So moles of S8 is given to us, and we're trying to find the number of sulfur atoms. So our plan should be from moles of sulfur atoms, sulfur molecule, from moles of S8 molecule. We want to find the number of S8 molecules. And once you find the number of S8 molecules, you're going to find the number of sulfur atoms. So we have 2.27 moles of S8 molecule. Each mole of S8 contains Avogadro's number of S8 molecules. Now each molecule of S8 contains 8 sulfur atoms. (1.09 times 10 to the 25 sulfur atoms. So far we showed you how to do conversions in between mole and mass for just elements. But how do we do this when we have compounds? So we still use the molar mass of compounds to convert in between moles and mass. For example, you want to know the number of moles of sodium chloride in 253 grams of sodium chloride. So from mass of sodium chloride, we're trying to find the moles of sodium chloride. We still have to use the molar mass. Now you're going to have to use the molar mass of sodium chloride. So finding the molar mass of sodium chloride, that would be the mass of one sodium atom and one chlorine atom, which ends up to be 58.44 grams per mole of sodium chloride. So the unit of molar mass is grams per mole. Now starting with 253 grams of sodium chloride, each mole sodium chloride is 58.44 grams of sodium chloride, and that gives you the number of moles of sodium chloride. So still, when you have conversions between moles and mass, you use the molar mass. If you're looking at individual elements, you just use their atomic masses. If you're looking at compounds, you have to find the molar mass of the compounds. Let's look at another example. You want to know how many moles of titanium 4 chlorides are in 12.5 grams of titanium 4 chloride. So we need to convert from mass of titanium 4 chloride to moles of titanium 4 chloride. And in order to do this conversion, we're going to need to have the molar mass of titanium 4 chloride. So molar mass of titanium 4 chloride is the mass of one titanium atom, which is 47.90 grams, plus 4 chlorine, which is, each one is 35.45 grams. Therefore, the molar mass of titanium 4 chloride is 189.7 grams per mole. So now, to go back to our question, we have 12.5 grams of titanium 4 chloride. We know that each mole titanium 4 chloride is 189.7 grams of titanium 4 chloride. So grams and grams cancel out. That gives you the number of moles of titanium 4 chloride, which is 0.0659 moles titanium 4 chloride A. What is the mass of 3.45 moles of lithium oxide? So from moles, of lithium oxide, we want to find the mass of lithium oxide. So in order to do this, we're going to need to have the molar mass of lithium oxide. So 3.45 moles of lithium oxide. Now each mole lithium oxide is 29.88 grams of lithium oxide, and that gives you 103 grams of lithium oxide. What is the mass of 1.3 moles of phosphorus trihydride. So from moles of phosphorus trihydride, we want to find the mass of phosphorus trihydride. So in order to go from moles to mass, we're going to need to have the molar mass of phosphorus trihydride, which is the mass of 1 phosphorus and 3 hydrogens, which is 33.99 grams of phosphorus trihydride. And the answer is 41.8 grams of phosphorus trihydride. So let's look at another example. How many molecules of H2S are present in 7.53 grams of H2S? So question number 1 is how many molecules of H2S are present in 7.53 grams of H2S? And number 2, we want to know the number of hydrogen atoms in that sample. So let's focus on number 1 first. You want to know how many molecules of H2S are present in 7.53 grams of H2S. So in order to find the number of molecules from the mass of H2S, you want to find the moles using the molar mass. And then from the number of moles, you want to find the number of H2S molecules. So up to here is our solution map for question number 1. So in order to solve this, you're going to need to have the molar mass of H2S. So you have 7.53 grams of H2S. Each mole is 34.09 grams. And then we know that each mole contains Avogadro's number of H2S molecules. So that gives us 1.33 times 10 to the 23 molecules of H2S. Now let's look at the second part of this question. We want to know the number of hydrogen atoms in this sample. So we have the number of H2S molecules, and keep in mind that each H2S molecule has 2 hydrogen atoms. So using that as a conversion factor, you can find the number of hydrogen atoms. Let's look at another one. How many molecules of H2O2, which is hydrogen peroxide, are there in 0.759 grams of the compound? So mass of hydrogen peroxide is given, and we're trying to find the number of H2O2 molecules. So in order to find the number of molecules, we're gonna have to find the number of moles first. So from mass of H2O2, we wanna find moles of H2O2 first. And once we have the moles of hydrogen peroxide, we wanna find the number of hydrogen peroxide molecules. So 0.759 grams of hydrogen peroxide. Each mole hydrogen peroxide is 34.02 grams of hydrogen peroxide. So grams and grams cancel out. And then each mole hydrogen peroxide contains Avogadro number of hydrogen peroxide molecules. And that should be 1.34 times 10 to the 22nd hydrogen peroxide molecules.